Welcome to Lesson 214, Creating Equivalent Ratios Using Multiplication Tables. Today we're going to talk about how to use a multiplication table to create equivalent ratios and how to use a multiplication table to determine if ratios are equivalent. All right, so first we need to talk about what is an equivalent ratio. An equivalent ratio is two ratios that show the same comparison using different numbers. So if you have the ratio 2 to 3 and the ratio 4 to 6, these ratios will be considered equivalent because you can multiply 2 by 2 and 3 by 3 or by 2 and you will get 6 and 4. So if you take a look at these, your pictures would then have to be the same. So if I had 2 x's for every 3 o's, then if I had 1, 2, 3, 4 x's, I should have 6 o's, and that is the case. Since that is the case, that means that 2 to 3 is equivalent to 4 to 6. Right, so we've actually been doing a lot of work with equivalent ratios and just not really knowing it. And we've also talked about equivalent fractions. Equivalent fractions and equivalent ratios are much the same in how you get them. They are just not, they're not representing the same thing. So we really need to be careful with how we say it and with understanding what they represent. Because this does not represent 2 out of 12 pieces, which a fraction would. This says that there are 2 x's for every 12 p's that you see in a paragraph. Okay, so it's saying that there's this many of this and that many. It's not a part to a whole comparison. All right, so we're going to use the multiplication table to see if these two ratios are equivalent. So what I do is I look and I say, okay, 2, which is this column right here, to 12. And then I have 3 to 36. So I have to decide, I'm going to start with the 2 and the 3. So I have 2 and I have 3. So now if I go down to the 12, and then I go down to the 36, in order for these two to be equivalent, the numbers would have to match up next to each other. Because they don't match up next to each other, they are not equivalent. Right? So, like we said before, I'm going to erase this here. You do not need to erase yours or write this down. I just want to kind of give you an idea. So if I had 2 to 3 and 4 to 6. So 2 to 3, these would be equivalent because they line up with each other. All right, moving along. So 3 to 15 and 12 to 60. So I have 3 to 15, and I have 12 to 60. So because they're on the same lines, they are equivalent. Okay, and if you noticed when I did 2 to 3 before, I had to do it like this. So it would have to line up just like this as well. Everything would have to be on the same lines when you're comparing them. So the 3 and the 12, because they're in the same spots, are on the same line, and then the 15 and the 60 would need to be on the same lines. Okay. Now we can do this much the same. We can look at 2 to 7, and we can create ratios that are equivalent to 2 to 7 by using the multiplication chart. So I can say, well, if I have 4, then I know that I have to have 14. So I can say 4 to 14 is an equivalent ratio. Now I know we're going this way. It all depends on how much room you had. If this had gone to 15 back here, then we could have put 3 and 15 on the same level, but because it didn't, we had to go up and down. So either way you slice it, they need to be on those same lines. Or I could also say that if I had 10 for my first number, then I would have to go across to the 7 column, the same number, and have 35. And I could do that with any numbers here. Now I can't go over into the 3 column and use 21 and then use 56. That would not be an equivalent ratio to my original. You have to stay within your column, okay, because you're staying within the numbers within the multiples of that original number. So these are all your multiples of 2, these are all your multiples of 7. And if you remember how to work with equivalent fractions, you'll remember that we have to multiply the top and the bottom by the same number. Well, it's the same thing with ratios, and that's what you're doing here with your multiplication table. You're taking 2 and you're multiplying it by 2, so you have to do the same thing to the 7. And when you take 2 times 2, you get 4, and when you take 7 times 2, you get 14. So that's what we're doing here. We said, okay, well I have 2 and I'm going to multiply it by 5 and I get 10. So when I take 7 and multiply it by 5, I should get 35. So you're just using the multiplication table to really double check your answer. Alright, so what I'd like you to do here is I would like you to practice on your own. I'd like you to get me 2 ratios that are equivalent to 4 to 9, and when you come back, we'll check over your answer. Alright, so you have 4 to 9. And you could have done any of the following. You could have done, and I'll type them to make this go a little bit faster, 8 to 18. You could have done 12 to 27. You could have done 16 to 36. You could have done 20 to 45, 24 to 54, 28 to 63, 32 to 72, 36 to 81. I'm sorry, that should have been a 6, not an 8. 40 to 90. 44 to 99. You also, if you think about it, you could have gone up. But in this case, if we go up, we can only do 0 to 0. So that does not work because that is not part of the ratio. So you also want to check and see if you can go up as well. So if we had started with 8 to 18, we could have done 4 to 9 as one of our equivalent ratios. Okay, again, you're using multiplication to find your equivalent ratios, and you're using the multiplication chart to help you. Alright, so what I want you to do is I want you to use the multiplication table to determine if these ratios are equivalent or not. And then I want you to use the multiplication table to find 2 equivalent ratios for these following ratios. This is what needs to be completed for class. As always, if you have any questions, please be sure to post them to Edmodo so we can go over them in class.